Good afternoon, one and all. I am R. Kiran, Assistant Professor, Department of Mechanical Engineering. Today, in this video lecture, I am going to start the problems on cams. Today, in this class, I am going to start and explain the first type, that is the knife edge follower, and the motion is uniform velocity. So, this is the first problem today, and this is my 40th lecture on the subject kinematics of machinery. So this is the question. So in the university exam also, so this is the same pattern of giving the question. So in these CAMS problems, you have to carefully read the question, and next you are going to draw those displacement diagrams. So firstly, carefully study the problem. So a cam is given to the following motion to a knife edge follower. So the given type of follower is the knife edge follower, and outstroke during 60 degrees of cam rotation. So the outstroke angle is given as 60 degrees. So first one we are going to start with the outstroke only. So outstroke angle is 60 degrees. Then dwell for the next 30 degrees. So next step is the dwell. So dwell, it has 30 degrees of cam rotation. Next one, it is the return stroke, which is having 60 degrees of the cam rotation. Next, dwell for the remaining 210 degrees. Dwell for the remaining 210 degrees. So these are the information given for drawing the displacement diagram. So from this information, we are going to draw the displacement diagram, and then we need to calculate the maximum velocity for the outstroke and return stroke, and the maximum acceleration if they are given in the problem. So in this question they are given, and next the information is the stroke of the follower is 40 mm. So the stroke is given as, that is capital S is given as 40 mm. Next, minimum radius of the cam is 50 mm. Next we are going to draw the cam, that is it has a radius of 50 mm. The follower moves with uniform velocity. So the motion of the follower is uniform velocity motion during both the outstroke and the return stroke. Draw the profile of the cam when the axis of the follower passes through the axis of the camshaft. So this is the general one. And next they have given the axis of the follower is offset. So they have given the offset condition also. So we need to draw these cam diagrams for the general model and the offset model. So that is the given data. So they did not ask any of the velocity and acceleration type. So this is the basic type of question. So this is the given data for the question. So outstroke is given as 60 degrees, and dwell for the next 30 degrees, and next return stroke for the 60 degrees. So this is the information to draw the displacement diagram. So this is the displacement diagram to be drawn. First, so firstly you have to take the 360 degrees of the cam rotation to the length, that is the linear position. So this A to X line is calculated in the scaling position only. That is, by taking the scaling only we can draw this. So already చెప్పానమ్మా మీకు. సో స్కేలింగ్ లో మాత్రమే తీసుకోవాలి. స్కేలింగ్ అంటే ఇప్పుడు 360 డిగ్రీస్ మొత్తాన్ని కూడా మనం సెంటీమీటర్స్ లో కానీ ఎంఎంస్ లో కానీ కన్వర్ట్ చేయాలి. సో ఐఎమ్ టేకింగ్ హియర్ 1 centimeter is equal to 10 degrees. So I am taking this scale as 1 centimeter is equal to 10 degrees. 10 degrees. So this is the scale here. So the scale is 1 centimeter is equal to 10 degrees. Or you can take it as 1 centimeter is equal to 20 degrees also. So you can take both ways. So in total 36 centimeters is equal to, so in total 36 centimeter is equal to 360 degrees. So 36 centimeter is equal to 360 degrees. So in total we are taking the 36 centimeters. So this displacement diagram also been drawn in the chart only, not in the booklet or any other one. We have to draw it on the chart. So total ga 36 centimeters తీసుకోవాలన్నాను. So the length of the AX line is 36 centimeters. So which has an angle of 360 degrees. So first outstroke తీసుకోవాలి. So outstroke 60 degrees ఇచ్చారు. నెక్స్ట్ ఇక్కడ హైట్ కూడా తీసుకోవాలి కదా. సో AX length వచ్చేసరికి 36 centimeters. AY length. So AY అంటే stroke of the follower. So stroke of the follower already ఇచ్చారు 40 mm, that is 4 centimeters. So the length of the AY is 4 centimeters, that is 40 mm. So we have to draw a rectangle with a height of 40 mm and length of 36 mm. So 36 mm is to the scaling purpose. So that is why we are taking the 36 mm. So in total, the rectangle is to be drawn with a height of 40 mm and a length of 360 mm. Length of 360 mm. So first we have to divide the sections as the outstroke, dual, return stroke, and the dual sections. So in total there are 4 sections, that is outstroke, dual, return stroke, and dual. So first the outstroke. So outstroke given angle is 60 degrees. So we have to take it in the centimeters, that is 60 degrees means 6 centimeters. So the length of the outstroke is 6 centimeters. Next, the dual is given as 30 degrees. So 30 degrees means 3 centimeters. So from G to H, so the period is dwell period. Next, the return stroke has an angle of, that is next it's 60 degrees of rotation. So 60 degrees means 60 centimeters. So from dual position we have to take next is 6 mm, that is 60 mm, 6 centimeters, and last one dual for the remaining 210 degrees. So from here remaining 210 degrees, that is 26 centimeters have been taken as, sorry, 21 centimeters is taken as dual period. So that is the procedure for division of the displacement diagram. So first, for this first section, that is outstroke section. So these outstroke section have been divided into 6 equal parts. So the length of the outstroke is 6 centimeters, that is 60 degrees. So that is why we are taking it as 6 centimeters, because 1 centimeter is equal to 10 degrees. So the outstroke length has been divided into 6 equal parts, that is 6 centimeters have been divided into 6 equal parts, that is each has a length of, each part has a length of 10 mm. So there we get the positions as 1, 2, 3, 4, 5, 6. So those are the divisions. Next we need to join the AG line. So from this point and next to the topmost point of the outstroke, that is the last position of the outstroke, we need to join this line, and we need to indicate the points as the intersection points of the vertical lines as B, C, D, E, F. So we are putting the intersection points as B, C, D, and E and F. Thereby we get the curve, that is the uniform velocity curve, that is a straight line. So we are obtaining this curve, that is the pink line from A to G. Then we have the dual period, that in the dual period we remaining it in the straight line, that is we have to join from G to H. Then we have the return stroke area. So in the same process as we have done to the outstroke, we have to do it for the return stroke also. So the return stroke angle is also 60 degrees. So divide the return stroke also with 6 equal parts. So I am taking the points as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash, which indicates the 6 equal parts. Then join the line from H to P, that is a straight line with a scale. You have to draw a straight line with a scale, because in the uniform velocity all these lines have to be in the straight line only. So no curves have been represented. That's why we are taking a straight line here to join the H to P and indicate the points of the intersection lines as J, K, L, M, N and P. Then again join a straight line from P to the last position, that is X position, with a straight line. So therefore we get the diagram, the displacement diagram. So the height of the follower, that is the stroke of the follower, is 40, or in some problems they are giving it as lift of the follower. So lift and stroke is same. So there we have to draw this. So indicate the points as in the same manner, which is in the textbook model. So we have to indicate it as outstroke, dual, return stroke, and dual. So this is the construction of the displacement diagram, and indicate all the angles, that is the 60 degrees, 30 degrees, 60 degrees and 210 degrees with the parallel line. So this is the procedure for the given diagram, that is the displacement diagram. So draw a horizontal line AX, that is 360 degrees to some suitable scale, that is suitable scale means to some scale which is convenient to your mark, and on this line mark AS is equal to 60 degrees, that is AS means The length of the outstroke is 60 degrees to represent the outstroke of the follower, and ST is the dwell, and TP is the return stroke, and PX is the dwell period. Again it is the dwell period. So draw these lines. Next, draw the vertical line, that is AY, that is the stroke of the follower, which is equal to 40 mm, and complete a rectangle. Next, by obtaining the rectangle, we are going to divide this outstroke and return stroke into equal number of even parts. That is, we are taking it has 6 equal parts. So I have taken 6 equal parts for equal division, and draw vertical lines through each point. So we are taking the vertical lines through the each point. And then the follower moves with uniform velocity during outstroke and return stroke. The displacement diagrams consists only of the straight lines only. So we are drawing it with only the straight lines only. Then the dwell period is indicated as a straight line, that is no deflection is there. So next we have to draw the profile of the cam. So this is the first step in the question. So they have given the radius of the cam only. From that we are going to draw this profile of the cam, in which the axis of follower passes through the axis of the camshaft. So this is the knife edge follower. So the axis of the follower is going to intersect it with the axis of the cam, that is in the two centers is in the straight line motion. So first of all we need to draw a circle. So draw the circle with a radius of 50 mm. So they have given the radius of the cam as 50 mm. So draw the circle with a radius of 50 mm and make a point to the vertical position and draw this knife edge follower in this shape, that is in the pencil shape. We have to draw this knife edge follower. Then divide this circle. So divide this circle into degrees of cam, that is total 360 degrees. In the 360 degrees, you have to divide to the outstroke, dwell, return stroke, and remaining part is the dwell period. So first the outstroke, that is total having a 60 degrees. So use a protractor and make 60 degrees. So take 60 degrees angle from the O to S position. So that is A position to S position. Then divide the 60 degrees into 6 equal parts, because we have divided the outstroke into 6 equal parts. Therefore, we are dividing the outstroke angle also into 6 equal parts. So we are dividing this into 6 equal parts, in which it has each part has 10 degrees from A to S position. Next, we are taking the 30 degrees. So these 60 degrees, we have to extend these lines outside the circle. So we have to extend these lines outside the circle, and from the first point, that is the first point, this is the first division on the straight line. Take the length of 1 to B. So measure the length of 1B. So this is the 1B length line in the displacement diagram, and take the same length in the line also from 1 to the extended line. So ఇప్పుడు 1 దగ్గర నుంచి ఎక్స్టెండ్ చేసాం కదా మన లైన్, కొంచెం ఆ లైన్ మీదకి 1B ఎంత లెంత్ అయితే ఉందో డిస్ప్లేస్మెంట్ డయాగ్రామ్ లో ఇక్కడ కూడా అదే లెంత్ తోటి మార్క్ చేసుకో. నెక్స్ట్ take the same procedure for the remaining points also, for the remaining divisions also, that is 2C, 3D, 4E, 5F and 6G. So take the length of 2C, take the length of 2C and cut it down from 2 to the extend line and mark it as C. So in the same procedure, take the remaining positions also, that is 3 2D, 4E, 5F and 6G. Then we get a curve from these points. So draw the curve from the point A on a freehand curve. So join these points with a freehand curve and we will obtain a curve like this, which is in the pink color. Then divide the next, that is the dwell position, that is we are going to take the dwell as 30 degrees. So from the point S, take 30 degrees from there and take the radius as O2G, and with the help of a compass draw an arc from 6 to G to H, that is in the 30 degrees position. Then divide that from that line to 60 degrees, that is the return stroke. So the return stroke is the 60 degrees angle. Then divide this line to 60 degrees and divide it into 6 equal parts as we did in the displacement diagram. So displacement diagram అలాగే చేసాము, సేమ్ అదే 6 ఈక్వల్ పార్ట్స్ చేసుకొని మార్కింగ్ చేసుకోండి. 0 డాష్ 1 డాష్ 2 డాష్ 3 డాష్ 4 డాష్ 5 డాష్ అండ్ 6 dash, and then do the same procedure as we have did in the outstroke. So outstroke ఎలాగైతే చేసామో రిటర్న్ స్ట్రోక్ లో కూడా సేమ్ అలాగే చేసుకోండి. Then the remaining position of the curve is the dual thread. So we are taking on the circle only with this thickest line. So by the each point we have to draw these lines, that is the uniform velocity lines. So that is the procedure for drawing the profile of a cam when the axis of the follower passes through the axis of the camshaft. And next, this is the procedure for drawing the profile of the cam. So note down the procedure. So note down the procedure. If you have any doubt in the drawing the profile of the cam. So next we have to draw the offset follower, that is the profile of the cam when the axis of the follower is offset. Offset means the distance of the position from the axis of the cam, that is called as offset position. So the procedure is same for the both conditions, but we have to take the knife edge follower axis to the offset length, that is it is given as 20 mm. So 20 mm from the axis of the cam, the distance have been taken to the 20 mm distance. So here we can draw the circle, that is a small circle which represents the offset position, and from there we are going to start the position with the knife edge follower. So start with the A point. So take 60 degrees from the position, that is from the center of the camshaft to the 60 degrees position. So then we will obtain 60 degrees angle and divide the angle into 6 equal parts and mark those positions from the displacement diagram. So the procedure is same. Then we have to take the dwell period, which is the 30 degrees position from the camshaft circle, and the remaining procedure is same. Then draw the return stroke also with the same procedure. It has having a 60 degrees position. So it is having 60 degrees position, and divide the same into 6 equal parts. But the parts have been taken, the lines have been taken from this small circle, that is the offset circle. Next, the dwell period may be marking as the thick line with the pink line to the knife edge follower. So it may be indicated to the end position. So that is the procedure for drawing the offset follower, which is having a distance of 20 mm. So marking the distance as 20 mm. So this is the procedure for drawing the offset follower of the cam. So note down the procedure for drawing the offset follower and draw it carefully. So this is a simple process of starting the cams, and later we are going to take the extend one, that is drawing the uniform velocity, that is velocity diagram and acceleration diagrams. by this I am ending this class. Thank you.